Okay, so notes at 4, yep, this is notes at 4, number 1, 2, 3, at the very end. We're just practicing how to solve. Your mid-unit test tomorrow will not have solving questions that involve complex roots, but it will have most of the same skills we're about to practice, except for the I. The I is not going to be in there. But the I just comes from the square root of -1. So number 1 is in what form? Vertex form. If it's already in vertex form, we can go ahead and start solving by square roots. How do I do that? Subtract 1, good. So I've got 2 times x minus 2 squared is equal to -1. I'm trying to get x minus 2 squared by itself so that I can take the square root of both sides. What do I need to get rid of first? I need to divide by that 2. Yep, so divide by 2. And I get x minus 2 squared is equal to -1 over 2. Now what can I do? Square root both sides. So square root this side, square root that side. Make sure your square root goes over your entire fraction. What is the square root of x minus 2 squared? No. No. Absolute value of x minus 2. Good. Equals. Now this thing is a little problem. So we're going to do some scratch work out to the side. This thing is a problem. That is broken up into the square root of -1 over the square root of 2. You take the square root of the numerator and the denominator. What's the square root of -1? I. Good. So I in the numerator. And then the square root of 2 is in the denominator. Do we know the square root of 2? No, it's irrational. We can't have an irrational number in the denominator of a fraction. So taking it back to geometry, how do we fix this? Multiply top and bottom by the square root of 2. What am I really multiplying by there? A 1. It's called a well-chosen 1 because we choose it wisely to help us. On the top, I'm going to be multiplying I and the square root of 2. What do I get there? Just I first and then the square root of 2. Over, on the bottom, we're going to be multiplying the square root of 2 times the square root of 2. What is that? The square root of 4, which is 2. 2 is a rational number. It's in our denominator, so we're good to go. That's why I wrote it in our absolute value equation, because after we do that work, then we're good to go. Well, where do I go from here? Piecewise. The absolute value of x minus 2 is equivalent to x minus 2 for some domain and negative times x minus 2 for some domain. What does the minus 2 do to your graph? Moves your vertex right 2. So where will my vertex be now? Close? 2, 0. So that means the first one's going to be for all x's greater than or equal to 2. And the second one is for all the x's less than 2. Knowing that the x minus 2 moves to the right 2 tells you where to start your domain. And then from there, we can solve both of our equations. And so I'm going to use my first domain, which is x is greater than or equal to 2. My first part of my piecewise, which is just x minus 2, equals, and then I'm going to set it equal to what my absolute value equation was equal to, which is I square root of 2 over 2. How do I solve for x? Add 2. What kind of number is 2? Rational and? Also starts with an R. Real. Your real number goes first, so 2. Notice I makes the I square root of 2 over 2 imaginary. What's the sign on I square root of 2 over 2? Plus. So adding I square root of 2 over 2. Real part first, imaginary part second, and that's where it stays. For my other equation, I'll have my other domain, x is less than 2. And that equation will be negative times x minus 2 equals, again, what my absolute value equation is equal to, I square root of 2 over 2. I left my negative out because I actually find it a little bit easier to divide by my negative first. What's the only thing dividing by a -1 does? Changes the sign on that right side and gets rid of your negative on the left side. So that's going to be negative I square root of 2 over 2 now. And then after this, it's just the same step I did for my other equation. I'm just going to add 2 to both sides. I'm going to have to write that. I can actually write that below. We're going to do number 3 on the back of your paper, so you have some room down below. X equals my real part is going to be 2 minus your imaginary part, I square root of 2 over 2. Which one? In the absolute value? No. Yeah. I find it easier or more efficient to divide by the -1 first and then add 2. It just takes me fewer steps. What's the same in your answers? The I squared of 2 over 2, that's good. The imaginary part's the same. What's also the same? The positive 2 in the front. Do we remember what that positive 2 represents? It's your axis of symmetry. So it should be the same in both of your answers. What that's saying is your axis of symmetry on your graph is 2. So we know that this thing is not going to hit the x-axis because it has imaginary roots. But our axis of symmetry is x equals 2, which means my parabola, does it open up or down? Opens up. So my parabola is going to open up, and the distance from the axis of symmetry that my imaginary roots are is the I squared of 2 over 2. Questions on that? Do what? No what? The 2? I know that it opens up. I know it's not going to cross the x-axis because I have imaginary roots. And then I know that the axis of symmetry is where my solution starts, so 2 is my axis of symmetry. So I just sketched it. It was just a rough sketch. This imaginary part is how far your solutions are from your axis of symmetry on both sides. No, you don't have to sketch that. No, I was just talking about it. Questions on this one? Let's do number 2. How do I start number 2? Ooh, what form is this almost in? Almost in standard. So how do I start this one? Add 4. Why are we adding 4? So that it equals 0, so that we can do what? You could. What should you do before you complete the square? You should try to factor it for at least a minute. If you don't get it after a minute, then you can try to complete the square. If you try to factor it, what will you find out? This one's not factorable, but on your test tomorrow, I would definitely try to factor first, because if it's factorable, then it looks like your opener, and you just set your factors equal to 0 and go from there. This one's not factorable, so let's go ahead and start completing the square. For completing the square, you have to group the first 2 terms first, so 3x squared plus 6x plus blank. You have to push that 4 outside first before you take a greatest common factor, because the 4 is the first thing that's not helping you make a square. From here, now you take out your greatest common factor. If you take it out early, it's going to mess everything up. So when you're completing the square to get vertex form, make sure to push the constant out first, then take your greatest common factor. What's my greatest common factor? 3. And what will I have left when I take that 3 out? X squared plus 2x plus blank plus 4 minus blank equals 0. The whole point of completing the square is to get vertex form, and then from vertex form we can solve by square roots. We're factoring into a square, so the 3 stays in the front. They are going to be x plus 1 and x plus 1. Working backwards, what's 1 times 1? 1, but that's not really a 1. It is a 3. So that means what goes on the end? Minus 3 minus 3. What's 4 minus 3? Positive 1, and that equals 0. Once you're here, you're ready for vertex form. So 3 times x plus 1 squared plus 1 equals 0. I'll let you catch up for a few seconds. Yeah, it's still equal to 0. Yeah, the question was, do I have to put equal to 0? Yeah, you should include it in every step because it's still an equation equal to 0. How do I solve this equation? Subtract 1, good. And I've got 3 times x plus 1 squared is equal to -1. Yeah. Now what? The backside's blank. You could use the backside. Just label number 2 and keep it going. Yep, divide by 3. So x plus 1 squared is equal to -1/3. Now what? square root. So I'm going to end up with the absolute value of x plus 1 is equal to, I've got the square root of -1 on the top, which is what? I. And then I've got the square root of 3 on the bottom. How do I fix that? Yep, multiply by the square root of 3 top and bottom. I'm really multiplying by a well-chosen 1. On the top, I'm going to have I square root of 3. What am I going to have on the bottom? 3. Because the square root of 3 times the square root of 3 is the square root of 9, which is 3. Yes, if you do it correctly. From here, we're ready for piecewise. I would move this up if I could, but I can't move it up anymore. So, piecewise, and then I'm going to bring it back up top. Actually, yeah, it's fine. Piecewise, I've got x plus 1 and negative times x plus 1. What does the x plus 1 do to your graph? Left 1. If I move to the left 1, where's my domain splitting off? -1. So x is greater than or equal to -1, and x is less than -1. Once you get those, we're ready to solve. I think I could do it off to the right side. So for x is greater than or equal to -1, I'm going to have, oh gosh, I got to look at the bottom, x plus 1 is equal to I square root of 3 over 3. Yeah? Only thing we have to do here is subtract 1 from both sides. Your -1 is your real part, plus your imaginary part, I square root of 3 over 3. What do you know your next answer should start with? It should start with 1. And it should be what we call a conjugate pair. It should be plus and minus, the same thing. But we have to show the work. Everything that I'm showing on the board is what I expect from you on a test. So I know that it's a lot, but I need to know that you understand what we're doing. It's x is less than -1, right? Negative times x plus 1 is equal to I square root of 3 over 3. I'm going to divide by -1 on both sides. The only thing that does is change my sign. So x plus 1 is equal to negative I square root of 3 over 3. And then same step for this one. We're going to subtract 1 from both sides. So x is equal to, oh, did I subtract 1? Oh, I missed the negative, didn't I? -1 plus I square root of 3 over 3. Hey, look, I found my mistake because I knew what I should have expected. -1 minus I square root of 3 over 3. What's your axis of symmetry? X equals -1. Yep, that's why both answers started with a x equals -1. And then the imaginary part. The imaginary part should also be the same. The only difference in your answers is the plus or the minus, but remember, we don't shortcut to get there. You show me the work to get there. When you're ready, we're going to do number 3 on the back because we don't have enough room for number 3. Number 3 is a lot nicer than these two are, though. I know it doesn't look it, but it is a lot nicer. -1/2 x squared equals 2x plus 3. Did I get that right? Man, look at me go. I didn't even look. Hey, what could make your life a whole lot easier right now, even though you might have to deal with it later? Do what? Do what? Yeah, we could get rid of the fraction. Now, we might have to deal with it later. Who knows? But we could get rid of it right now. How? Multiply by 2 on everything. So let's go ahead and do that. If it can make my life easier right now, I'd be willing to deal with it later. So I'm just going to do this here. You cannot do this when you're completing the square because you can't multiply f of x by 2. You cannot do this if it were an expression. You can only do this if you are solving an equation. What does an equation have in it? An equal sign. That's why you can do it in an equation, because you have two sides that you can do it to. From here, do what? You can. It'll change what you move next, but you can leave it. This will be -1x squared equals 4x plus 6. And we really like our x squared to be positive. So how do I make x squared positive? What? You can. That'll be more work than it's worth. Yeah, I can add it to the other side because what am I trying to get here? I'm trying to get it equal to 0, so I can add it to the other side. That means I'll have 0 equals x squared plus 4x plus 6, which is just fine. Can I factor this? What are your factors of 6? 3 and 2, 6 and 1. If I add 3 and 2, what do I get? 5. If I subtract 3 and 2, what do I get? 1. None of those are 4. What about 6 and 1? Add them. 7, subtract them. 5. None of those are 4. So it's not factorable. And I went through that because it just has an x squared. If it had a number in front of x squared, that might make it a little bit more difficult, and you should check to see if it's factorable. But it's not factorable, so what do? Complete the square. So let's group, so 0 equals, let's group x squared plus 4x. We're going to push that 6 outside with a plus blank, and then plus 6 minus blank. Nothing's in front of x squared that I need to take out, so I'm ready to factor into a square. What will my factors say? X plus 2, x plus 2. Remember, the sides of a square are the same, so your factors have to be the same. Let's work backwards. 2 times 2 is 4, and that means what goes on the outside? Negative 4. You already have the minus there. What's 6 minus 4? 2. We are ready for vertex form, so 0 equals x plus 2 squared plus 2. The whole purpose of completing the square is to get it in vertex form. It does reveal the vertex, and then from there we can solve by square roots. How do I solve by square roots? Subtract 2. I get negative 2 is equal to x plus 2 squared. Notice we don't have it equal to a fraction, so automatically it's a little bit easier than the other two that we've done. How do I go from here? Square root both sides. When you're taking the square root of negative 2, that's really the square root of negative 1 times 2. Which one of those do you know the square root of? Negative 1, which is I. What do you not know the square root of? 2. So it's going to stay I square root of 2. Equals what? Absolute value of x plus 2. Please don't forget the absolute value. So absolute value of x plus 2. From here, we're ready for our piecewise. I'll have x plus 2 and negative times x plus 2. And what does the x plus 2 do to your graph? Moves it left 2. So that tells me that the domain is going to split at negative 2. So x is greater than or equal to negative 2, and x is less than negative 2. From here, I'll take my first domain, which is x is greater than or equal to negative 2. My equation for that is going to come from the first part of my piecewise, which is x plus 2. Is equal to what your absolute value equation was equal to, which is I square root of 2. I don't know why that zoomed out all of a sudden. From there, what's the only thing I have to do to solve? Minus 2. Good. I'm hoping we're quiet because we're already working ahead because we know how to do this. Real part is negative 2. Imaginary part is plus I square root of 2. Your other equation comes from your other domain. X is less than negative 2. That part of my piecewise is negative times x plus 2. And that's equal to, again, what my absolute value was equal to, I square root of 2. I find it a little bit nicer just to divide by negative 1 here. So x plus 2 is equal to negative I squared root of 2. And from there, it's the same thing as the last one. We're going to subtract 2 from both sides. X equals your real part is negative 2, minus your imaginary part is I square root of 2. Notice both of your answers had a -2 in the beginning, an I squared of 2 on the end, and they're separated by a plus or a minus. That's a good sign, but you do have to show all that work to get there. If you followed this last example, that's good. That's a good sign. Make sure that we're staying on top of our homework this week, because your homework is going to help you study for what's coming up. When is the first time that you could see complex on an assessment? On Tuesday, when you have your quiz 2. It's not going to be on your mid-unit test tomorrow. What we're going to do now is we're going to do a group quadratics practice that'll help you study for your test tomorrow, okay? And I'll give that to you in just a second.